this lesson here will be about powers and roots, and probably more specifically we're going to be working with square roots. This is going to be an algebraic extension on examples that look like the square root of 20, the square root of 18, the square root of 12x squared, y to the third. A lot of times we may be asked to simplify these. So again, most of these types of questions you just really just see in math textbooks, but they may appear in the GED, and if you have a little bit of wits about you, these actually aren't that bad, and a lot of these are due sometimes in a big old word problem. Some things to know though is, one thing we need to pick up on is this concept of a perfect square. So a perfect square. Perfect square, what you do is you pick a number and you square it, and the answer is called a perfect square. So I pick 5, I square it, 5 times 5 gives me 25, so 25 is called the perfect square. I pick 6 squared, 6 times 6 gives me 36, so 6 is called, or 36 is called a perfect square. I pick 7 squared, 7 times 7 is 49, therefore 49 is a perfect square. Now what's kind of nice about perfect squares is this. I can actually take the square root of them. So notice that the square root of 25 is the same thing as 5 times 5, therefore 5 comes out. I want you to notice something a little bit different here. Notice how I wrote this middle piece in 5 times 5. What you notice is there's 2 5s inside there, and what we kind of do is we just bring 1 5 out of the radical symbol. Remember how I use that word radical? So if I have this radical sign, I have 2 of the same factors inside. 1 comes out. Okay, 2 go in, 1 comes out. So when I have the square root of 36, I have 6 times 6. Notice how there's 2 6s here, but only 1 6 will come out. That's very important as we move forward. Square root of 49, notice how we have the 7 times 7. 2 go in, 1 7 comes out. That's very powerful. Something else we want to pick up on is this word prime numbers. Prime numbers have exactly 2 factors, 1 and itself. So they're very important numbers. The most popular is the 2, 3, 5, 7, 11. We use those the most. And also what we have is what's called a prime factorization. A prime factorization is a product of prime numbers. And remember, product implies multiplication. So these prime numbers are all connected by multiplication. So what I want to do is I want to talk about a prime factorization of 20. To factor the 20, what we do is we look for its numbers that go into it. It's what we call its divisors. So these 2, 3s, 5s, 7s, 11s, they become our divisors of the 20. And what I do is I keep it kind of simple. I just start with most popular, which is the 2, and see what he does. What I ask myself, can 2 divide into 20? Well, since 20 is even, I know it does. So if I'm not sure, I can type 20 divided by 2 into the calculator. It gives me 10, or just think, well, 2 times 10 is 20. So 2 comes down, 10 comes down. So 2 times 10 is 20. 2 is a prime number, but 10 is not. 10 is still even. And that tells me that 2 can also go into that. So I break the 10 down with a 2. 2 times 5 gives me my 10. Now, this 5 is not, well actually, 5 is a prime number. So the 5 does not break down, so what we know is 5 will go into 5 one time. That little 1 there tells me that I've completed my factorization. My prime factorization are those 3 numbers there. It's 2 times 2 times 5. So when I come to this problem over here, square root of 20, what I'm allowed to do with the square root of 20 is I'm allowed to rewrite it as a prime factorization, 2 times 2 times 20. I'm sorry, 2 times 2 times 5. I'm allowed to make a prime factorization out of it. Now to simplify it, since it's a square root, I'm looking for the 2 go in, the 1 go out concept. Notice how there's 2 2's here. What that tells me then is, since there's 2 2's inside there, I'm only going to bring 1 2 out. So 2 comes out, so they're gone. But notice how this 5, he doesn't have a 2, so he stays in there. He remains inside the square root symbol. So it gives me 2 times the square root of 5. Now in your calculator, there is a way to just type the square root of 25 into the calculator. Remember, I'm sorry, the square root of 20. We can actually just type in the square root of 20 into the calculator as well. if we do that, we have to find that square root key. And remember, it was right above the x squared key. So to do the square root, I hit the second button and hit the x squared button, which gives me my square root symbol. So second square root, and then put the 20 in there. If I hit enter, notice it gives me 2 times the square root of 5. That's where that's actually coming from. If you hit the toggle button down here, if you toggle it, it'll give you a decimal number as well. So that toggle button will flip it actually into a decimal. And notice how it's a crazy decimal too. That kind of tells you that you have these radicals. Radicals, when you change them to decimals, will always be these decimals that you always have to round. So if I round to the hundredths place, that would be 4.7 or 4.47 or 4.48. Well, that 2 would tell me that it's closer to 4.47, so we just call it 4.7. And that's what we refer to as an estimation. We round it. Okay. Now, if I look at this 18, I can do a prime factorization on this 18. Now you're kind of getting the idea, why do I want to do a prime factorization? That's going to be how I'm going to simplify the square root of 18 without a calculator. So again, I use my most popular prime numbers, 2, 3, 5, 7, 11. We'll start with 2. Since 18 is even, I know that 2 times 9 is 18. 9 is not prime. I know 2 doesn't work, but I do know 3 does. So I know that 3 goes into 9 3 times. Notice how 3 is a prime number. So one thing that's going to go into 3 is itself. So I put the 3 over here, and 3 goes into 3 one time. That 1 signifies that I've completed my prime factorization. This left side is your prime factorization. So what I'm allowed to do with the square root of 18 is I'm allowed to change it to the square root of its prime factorization, 2 times 3 times 3. Now to simplify these, what I'm looking for is that perfect square. Or in other words, 2 go in, 1 comes out. And notice how you have a pair of 3's here. Since there's a pair of 3's, a 3 comes out. It's no longer inside there, but that 2 is left inside there. So 2 has to stay in because he doesn't have to allow him to go out. It's got to be 2 to come out. So he has to stay in. He's still locked up. So 3 square root of 2. Now again, if we have the calculator available, we can do the second button and do the square root of 18, hit enter, and it'll give you that answer of 3 square root of 2. And if you want that decimal version of it, that's where that toggle button comes in. You have to toggle it. And that gives me like 4.24 blah, 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 blah. So we don't want to do all that blah, blah stuff, so we just round it. This time I'm just going to round it to the tenths place. So 4.2 or 4.3. Looks like since there's a 4 in that hundredths place, this is going to remain as 4.2. So it'll estimate. Now, in the GED test, they'll probably tell you where to round, whether it's the tenths place or the hundredths place, sometimes even to the nearest whole number. So we'll do that. Now to do 12 x squared y to the third, the 12, we can still do a prime factorization on this. Variable stuff, we treat that a little bit differently. So 12, I know, again, my favorite prime numbers are 2, 3, 5, 7, 11. They're the most popular. They usually work all the time. So 2 goes into 12 6 times. 6 is not prime because 2 goes into it. 2 goes into 6 3 times. 3 is a prime number, and we know that 3 goes into 3 goes into 3 one time. Again, my prime factorization is this side over here. 2 times 3 would be the same thing as 12, but we call that a prime factorization. So what we're going to do then is we're going to change this 12 to its prime numbers, 2 times 2 times 3. And then the x squared, what we're going to do is follow what the exponent means. X squared means x times x. And I'm going to follow what the power of 3 means. Y cubed means y times y times y. So we do that. So what we are allowed to do, though, is 2 go in, 1 comes out. That's how we work with square roots. There's a pair of 2's, so a 2 comes out. There's not a pair of 3's, so the 3 is locked in. There's a pair of x's, so they come out as an x. There's a pair of y's, so I can pair them out, and a y comes out. And what's not paired up has to stay. So what has to stay is a 3 and the y. So 3y has to stay inside there, and that would be how you would simplify that. And note that you really can't put that one in the calculator, so then all of a sudden you have to understand a little bit about how to simplify square roots. And that's my story. So we'll see you in class, hopefully, and we'll see if we can get this to work out for us. Take care.